Problems in Fourier cosine transform. Find the Fourier cosine transform of f of x is equal to e to the power minus ax, and hence evaluate integral 0 to infinity dx divided by x square plus a square the whole square. Now in this problem we have to find Fourier cosine transform of e to the power minus ax. That is fc of e to the power minus ax. And second we have to calculate integral 0 to infinity dx divided by x square plus a square the whole square. In this problem they have given f of x is equal to e to the power minus ax. Now first we can solve the first one, that is we have to find Fourier cosine transform of e to the power minus ax. For finding Fourier cosine transform of e to the power minus ax, we need to know the formula of Fourier cosine transform. Fourier cosine transform is fc of s, which is equal to fc of f of x, which is equal to root of 2 by pi integral 0 to infinity f of x into cos xx into dx. This is the formula for Fourier cosine transform. In this formula, directly we are going to substitute the value of f of x. Here, f of x is equal to e to the power minus ax. Therefore, the formula becomes fc of e to the power minus ax, which is equal to root of 2 by pi integral 0 to infinity e to the power minus ax into cos xx into dx. So now to evaluate the right hand side, we have to apply the formula in integration. That is integral 0 to infinity e to the power minus ax cos dx dx, which is equal to a by a square plus b square. This formula directly we can apply in the right hand side. In the right hand side, here a also equal to a and b is equal to s. Therefore, the Fourier cosine transform of e to the power minus ax become root of 2 by pi and then a divided by a square plus s square. The b alone is replaced as s here. That's all. We have calculated the Fourier cosine transform of e to the power minus ax. Next, we are going to find integral 0 to infinity dx divided by x square plus a square the whole square. So for this, we have to apply the Parseval's identity formula. Parseval's identity is integral 0 to infinity modulus of fc of s the whole square into ds, which is equal to integral 0 to infinity modulus of f of x the whole square into dx. In Parseval's identity formula, we can directly substitute the value of Fourier cosine transform of e to the power minus ax and f of x value. Fourier cosine transform of e to the power minus ax already we have calculated as root of 2 by pi into a by a square plus x square. So that value we are going to substitute in the left hand side, and in the right hand side we are going to substitute the value of f of x. Therefore, the left hand side becomes integral 0 to infinity root of 2 by pi into a by a square plus s square. The whole square, since it is modulus and it is an even function, we can write like this: whole square into ds, which is equal to integral 0 to infinity f of x is e to the power minus ax the whole square into dx. Now the left hand side, when you simplify, 2 root of 2 by pi the whole square becomes 2 by pi. That we can take it outside. It is a constant term. And one more constant we have, that is a square. So 2a square by pi is a constant term. We can take it outside. And you'll get integral 0 to infinity ds divided by a square plus s square the whole square. And in the right hand side, integral 0 to infinity. Now we have to expand the e power minus ax the whole square. For that, we know one formula. A power m the whole power n can be written as a power m into n. So we are going to apply this formula in the right hand side. Therefore, e power minus ax the whole square become e to the power minus 2ax into dx. Now next step is integration of e power minus 2ax. So for that again we want to know the formula of integral e power ax dx. e power ax dx is nothing but e power ax divided by x coefficient, that is a. So based on this formula, e power minus 2ax dx can be written as e to the power minus 2ax divided by x coefficient, that is minus 2a. Integration over. So apply the limits. Limits are 0 to infinity. Now in the next step, you can take the constant term outside, that is minus 1 by 2a is a constant term, and you have to apply the upper limit as well as lower limit in the place of x. So therefore, it becomes e to the power minus 2a into infinity minus e to the power minus 2a into 0. Now when you multiply it with infinity with any term, it becomes infinity. Therefore, the right hand side becomes minus 1 by 2a into e to the power minus infinity minus e to the power 0. So now we want to apply the formula for e power minus infinity and e power 0. We know that e power minus infinity is equal to 0 and e power 0 is equal to 1. These values you can substitute in the right hand side. Therefore, the right hand side become now minus 1 by 2a into 0 minus 1. Therefore, when you simplify, you'll get plus 1 by 2a. Now, in the left hand side, you have 2a square by 5 into integral 0 to infinity ds divided by a square plus a square the whole square. Now we can bring that 2a square by 5 to the right hand side. When it comes to the right hand side, it becomes 1 by 2a into 5 by 2a square. So the right hand side will get 5 by 4a cube. Now we have to replace s by x because in the given problem it is given in terms of x. Therefore, integral 0 to infinity dx divided by a square plus x square the whole square is equal to 5 divided by 4a cube. This is the required result.